Trigonometry we have done. Coming to third chapter, that is matrices. So in matrices we have first exercise 3.1 starting from question number 1. Question number 1 is asking about the order of matrix. Here it is given matrix A is equal to having 12 elements. So we need to find the order of matrix. As we aware the fact, to find order of matrix, just calculate number of rows 1, 2, 3 and column 1, 2, 3, 4. So this matrix having 3 rows and 4 column. So here we can say order of matrix is nothing but 3 rows, 4 column. Now coming to the question number 2, the number of elements. Here you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or just simplify this term 12. This will ultimately give you 12. That means the number of elements 12. Now moving further, write the elements A13, A21, A33, A24, A23. Here the subscript giving 1, 3, that means row 1, column 3. Row 1, column 3. That is 19. So you are 19. Now second one, A21. Here the subscript is 2. Second row, first column. Second row, first column. Second row, first column, 35. Second row, first column, 35. A33. Third row, third column. Third row, third column. Third row, third column. -5. A24. Second row, fourth column. Second row, fourth column. Second row, fourth column. 12. So you are nothing but 12. Now final elements. Second row, third column. Second row, third column. Second row, third column. 5 upon 2. Second row, third column. 5 upon 2. So coming to second question. Now having solved question number 1, let's move on question number 2. Question number 2 based on statement. Statement is asking about possible order it can have, provided 24 elements. So here 24 elements. We have 24 elements. So how many possible matrices we should have? So simply write 24 and deconstruct it into product of two natural number. Product of two natural number. So what will be the product of two natural number? 24. 1 into 24, first one. We can say reverse order of this one, that is 24 into 1. Moving ahead, 2. 1, 2. 12 2 ja 24. Reverse order 12 into 2. After 2, 3. Deconstruct with natural number 3. 3 into 4. No, 3 into 8. 3 into 8. Reverse order 8 into 3. 24. Exactly. 3. 4. 4 into 6. Reverse the order 6 into 4. 1, 2, 3, 4, 5, 6, 7, 8. Now 8, 8, 9, 9. Okay, question number 2 completed. Now question number 3. Question number 3 more or less identical in nature. So here in place of 24 we have 18. 18 element, you have to say possible order of the matrix. So in the same manner we need to deconstruct 18 elements into product of two natural number. 18. So 18. Let's deconstruct 18 into product of two natural number. 18. 1 into 18. Reverse order 18 into 1. 2 into 9, reverse order, 9 into 2, 3. 3 into 6, reverse order, 6 into 3, 4, 5, 6, 7, 8, 9, 9, 9, 9, 1, 2, 3, 4, 5, 6. That means 6. On deconstructing 18 into product of natural number, we get total number 6. 6 is the total number of order we have, consisting 18 elements. Now, moving further, what if it has 8 elements? Very simple. 5 elements, that means 5 elements. So, either 5 into 1 or reverse order 1 into 5. So, question number 2 completed. So, keeping our momentum with solving question number 1, 2, 3. Now we are in question number 4. Here the question number 4 is asking about construct a 2 into 2 matrix where A equals Aij, whose elements Aij is equal to 1 plus j power square upon 2. So if we talk about square matrix where row is equal to column, so for 2 into 2 matrix we have elements just like A11, A12, A21, A22. Following the pattern of elements having A11, we can simply put the value of I1, J1. We get element corresponding to A11. In a similar manner, we can also find A12, A21, A22. So let's start. Here A11, that means 1 plus 1 square upon 2, which implies 2 square 4 upon 2, 2. A12, I1, J2 whole square upon 2, 3 square 9 upon 2. Coming to row 2, A21 having value I equals to 2 plus J1 whole square upon 2 gives 3 square upon 2. That means 9 upon 2. Same element. Moving further with A22, we have in place of I 2, in place of J 2 whole square upon 2, which give 4 square 16 upon 2, 2 8 ja 16. So we can construct matrix analogous to this ideal square matrix, something like that. A11 2, A12 9 upon 2, A21 9 upon 2, A22 8. So square matrix having 4 element with 2 row 2 column. Okay, let's have a look in question number 2. Similar pattern. So here we need to plug the value I1, J1 for element A11. 1 upon 1 gives 1. A12, A1 upon 2, which implies 1 upon 2. A21, 1 upon, no, 2 upon 1 gives 2. A22, 2 upon 2, 1. We get matrix 1, 1 upon 2, 2, 1. Let's have a look in question number 2. Similar pattern. So here we need to plug the value I1 J1 for element A11. 1 upon 1 gives 1. A12 A1 upon 2, which implies 1 upon 2. A21 1 upon 2 upon 1 gives 2. A22 2 upon 2 1. We get matrix 1 1 upon 2 2 1. Let's have a look in question number 2. Similar pattern. So here we need to plug the value I1 J1 for element A11. 1 upon 1 gives 1. A12 A1 upon 2, which implies 1 upon 2. A21 1 upon 2 upon 1 gives 2. A22 2 upon 2 1. We get matrix 1 1 upon 2 2 1. Let's move on. Third one, we have to construct same square matrix having corresponding elements A11 A12 with row A21 A22 second row. So first of all, we need to construct an ideal matrix having element A11 A12 A21 A22. So for A11 we simply put the value of I1 2 into 1 so 2 square, which give 3 square upon 2 9 upon 2. A12 1 plus 2 into 2 whole square upon 2 4 plus 5 square 25 upon 2. Moving further with row 1 row second A21, where the value of I 2 with value of J 1, we get 2 plus 2 4 square 16 upon 2 gives 8. A22 2 plus 2 into 2 whole square upon 2 4 plus 2 6 36 upon 2 18. Now with this element we can construct a square matrix having elements in place of A11 9 upon 2, in place of A12 25 upon 2, in place of A21 8, in place of A22 18. So let's move further. Maintaining the rhythm, let's solve another question. Here we need to find the value of corresponding variable x, y, z. So x 1, y 4, z 3. So simple. Simply write the answer. X is equal to 1, y is equal to 4, z is equal to 3. This question depends upon presence of mind. Okay, let's move. Question number 6, second one. Here we need to find the value of x, y, x and y. We can conclude from first row that x plus y is equals to 6. And from second row, second column, we conclude x, y is equal to 8. Two equation, two variable. So we can find the value of x and y very easily by solving these two equations. So let's move on. So if we take the value of x is equal to 8 upon y and putting this value in equation, suppose 1 and this is 2. So what we get on putting the value of x, we get equation, something like that. On simplifying this expression, we get 8 plus y square is equal to 6y. Now further solving this equation, we are witnessing quadratic equation. So in order to solve quadratic equation, we need to put equals to 0. Now kindly factorize this expression. Y square 6y, 4y minus 2y plus 8 is equal to 0. y minus 4 minus 2y minus 4, 0. So here we get the value of y nothing but 2 and 4. The value of y 2 and 4. Now, question number 3. Here we have 3 equation, 3 variable. X, Y, Z, 3 variable. 3 expression with 1, 2, 3. 3 equation. So kindly write the expression x plus y plus z is equal to 9. X plus z is equal to 5. Y plus z is equal to 7. So try to substitute any one of either x or z, either y or z. Here our brainstorming conclude that if we put x is equal to 5 minus z, y is equal to 7 minus z, we are on the approach of solving the value of x. So here on putting x and y in this equation, what we get 5 minus z plus 7 minus z plus z is equal to 9. Now further simplifying this equation, this expression, what we get z minus z answered 5 plus 7 12 minus z is equal to 9. So here we get z is equal to 3. So the value of z is 3. Now we can easily find the value of corresponding x and y. What we need to do, just kindly plug the value 3 here. We get 5 minus 3, 2. Plug the value here. We get 7 minus 3 is equal to 4. Now the value of x is 2, y is 4 and z is 3. So here the value. Let's move on. Question number 7. Question number 7 is asking about the value of corresponding A, B, C, and D. So here what we need to do, just write the expression corresponding to equation. That is, for first row, A minus B is equal to minus 1. First row, second column, 2A plus C is equal to 5. Second row, first column, 2A minus B is equal to 0. Second row, second column, 3C plus D is equal to 30. So among the 4 expression, easiest one is this. So here we can conclude B is equal to 2A. Now first equation, second equation, third equation, fourth equation. On putting the value of third equation, that is B is equal to 2A, in first equation we get B is equal to 2A. In equation 1 we get A is equal to 2A minus B is equal to minus 1. 2A minus B, B. 2A, sorry. A minus 2A is equal to minus 1. We get A is equal to 1. Now putting the value of A in equation second, A is equal to 1 in second, we get 2 into 1 plus C is equal to 5. So here the value of C is equal to 3. Here the value of C is equal to 3. As you know that B is equal to 2A, so kindly write B is equal to 2. Now D. How to find D? Just plug the value of C, 3 into 3 plus, what is the value of D? We need to find that 13. On simplifying this equation, 9 plus D is equal to 13. What we get? D is equal to 9 minus 13, 4. D is equal to 4. So these are the corresponding value. S is 1, C is 3, B2, D4. Now considering our order, we are in question number 8. So question number 8 is demanding about the condition which satisfy this matrix. So E is square matrix, as we aware the fact, in order to be square matrix, the number of row must equals to number of column. So here the number of row M must equal to the number of column. M no, B no, C yes. So C is the correct option. Let's move further question. Question number 9. Question number 9. Which of the given values of x and y make the following pair of matrices equal? So as we aware from the fact that in order to say two matrices equal, both having identical elements. So here in first row we have 3x plus 7 equals to 0. 5 is equal to y minus 2. Second row y plus 1 is equal to 8. Second row, second column 2 minus 6 is equal to 4. So wherever you have option in mathematics, try to plug the values provided in option. This will help you a lot. So here what we do, here we simply plug in the value and get checked which of the following option gets satisfied this matrices, in order to say both are identical. So now if we put the value of x is equal to 1 minus 1 upon 3, minus 1 upon 3. So here 3 into minus 1 upon 3 plus 7, 3 cancel. This will become minus, this will become 6. So no, you are not correct option. Not possible. See, y is equal to 7. Here we try to put the value of y is equal to 7. So y 7 plus 1 8. 8 yes, satisfying this y is equal to 7 value, gets satisfying the expression y plus 1 equals to 8. So we should take into account this option and this option. Now x is equal to minus 2 upon 3, x is equal to minus 2 upon 3, minus 2 upon 3 into 3 plus 7 get cancelled, minus 2 plus 5 is equal to 5, is equal to 5. No, this is not correct option, because this value did not satisfied in the equation. Now question number D. X is equal to minus 1 upon 3. Here if we take the value of x is equal to minus 4 upon 3, 3 into minus 1 upon 3 plus 7 is equal to 3 cancel, 6, obvious 6 as we have got in option A. Now for y plus 1, here we put the value of y minus 2 upon 3 plus 1, we get 3 minus 2, that means 1 upon 3. No, you are not correct option, that means we have with option B. So you are the correct option for this question. None of them satisfying the value given in expression. So now move on next question. Hello everyone, this is the last question of this exercise. This question is more about permutation and combination rather matrices. That means it is more PNC, less matrices. So now we have to remind the concept of permutation combination we studied in class 11. So here first of all we need to adjust matrices. Now 3 into 3, suppose A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the ideal matrices we have. Now the question is saying that each of the entry 0 or 1, either 0 or 1. So that means the possible value of one element 0 or 1. That means 2 factorial, 2 value. And how many places we can put this value? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So that means 2 factorial, how many times? 9 times. 9 times. How many times? 9 times. 9 possible way to put the value 0 or 1. It is a fundamental multiplication rule as we have studied in class 11. So in short we can say 2 factorial power 9 or 2 to the power 9. So the answer is, okay, just calculate. 2 2 ja 4, 4 2 ja 8, 8 2 ja 16, 8 2 2 ja 4, 4 2 ja 8. How many times? 4. That means 4 4 16, 4 4 16, and remaining 2 2. As we know that 16 square 256. 256 into 2. 256 into 2. That means 256 into 2 is the right answer. 512. D option. The option is correct. So we have completed exercise 3.1. Now coming to exercise 3.2. Stay tuned. We are coming with solution of 3.2. Just be patient. Okay.